Hello, and welcome to my second video on my differential equations series. In this video, we will discuss variable separable equations. So this pretty much means that we will have, say, an x and y and a dx and dy within a certain equation, and we're going to try to divide up one side to be all x's and one side to be all y's, and we would integrate to get to our equation, our solution. But in this case, I took a problem from video 2 of the ENGR 205 series about a circuit where we have a resistor of 100 ohms, a capacitor of 10 to minus 12 farads, and we're just having to figure, and for a certain time where E of t equals 5, and then we would solve for whenever Q of 0 equals 0. So I'm just going to go ahead and plug in all the values. So R 100, EQ, Q takes charge, ET is time, plus Q over C, and then negative 12, equals our E to T for whatever time, which is going to be 5 volts. This is for volts, by the way. It really matters. That's on the how you do variable separable. So in this case, I'm going to go ahead and divide over that 100. I can have no coefficient for that dq dt. And I'll move this 10 to the negative 12 up. So then say 10 to the 12 divided by 100, 10 to the 10th times q equals 0.05. Alright, so our next step is to subtract over this, the term 10 to the q. At 0.05 minus 10 to the 10th q. So now the next step is I'm going to divide over this term here and multiply this term to the other side. So then I'll have one side of all q's and one side of all t's. So now it means I'll have an integral of 1 over 0.05 minus 10 to the 10th q dq equals the integral of dt. So now when I integrate, this would be, I would have to find a coefficient to get by u du, and I'll multiply by negative 10 over 10. Sorry, negative 10 to the 10th over negative 10 to the 10th, a form of 1. So negative 10 to the 10th here, and divide that by negative 10 to the 10th. That's my form of 1. So now I have a du to my u. When I integrate, this will become 1 over negative 10 to the 10th times the natural log of 0.05 minus 10 to the 10th q. Absolute value, since it's an integral, and this will equal the integral of dt, which is just t, plus some constant. I want to say C1. So I could have put a constant on either side, but I just chose to put it on one because I'm just combining it together for the sake of the integral. So I don't have to have two constants and later combine them into to be some other C2 or C3. Now my next step is going to be to multiply this coefficient out front of the natural log, the 1 over negative 10 to the 10th, because I'm trying to get rid of the natural log, and I need to get it by itself. I can take the e, or make that the power e, so then 10 to the 10th, or negative 10 to the 10th, t plus, since I'm even multiplying by negative 10 to the 10th times some constant, I'm going to denote this constant as some new constant, C2. We can't just leave it as just C1 or C because it is a new constant at that point. So you need to denote a change in constants. You have the power of E for both sides. This is the log 0.05 minus 10 to the 10 times q equals e to the negative t. Now I have plus is c2, but if you remember your rule of exponents, when you multiply, say, x squared to x to the first, it becomes x cubed. You add up your exponents. So it's just the same thing here, where it's I can have some e to the negative 10th to the 10th times t. Then I have this plus c2. I can separate this into e to c2, and then now denote this new e to the c2 as another constant, which I'm going to call c3. All right, now I'm going to go ahead and go back up to wherever I had for q0. So it told me that at q0, so whenever t equals 0, charge equals 0. So now I'm going to solve for this c3. So if q 0 equals 0, then that means this q equals 0 for it, and this t equals 0. So that implies that 0.05 minus 0 equals e to the 0 times c3. I'll also just put that right there so you can see it and in each equation. So that e to the 0 is just 1. This is just 0, so I don't need to worry about the minus 0. So then that implies my c3 equals 0.05, and that implies that my equation is 0.05 minus 10 to the 10th q equals e to the negative 10th to the 10th times t times the c3, which I'm just going to move this equation over, the equation sign over, like put 0.05 there. And if you feel like you need to solve for q, it's not that big of a deal. It's just, it would be q equals 0.05 e to the negative 10th to t minus 0.05 over 10 to the 10th. And you can simplify that down further if you would like. The main thing to take from this problem is how to separate your variables into one side versus the other, so then you can then integrate it in terms of that variable. And that's pretty much the main thing. And it's really hard to really know if something's variable separable. It's almost like you have to do a trial and error. I know that's not the most systematic way or method to do, but you just gotta try. And if you don't, there will be many other methods. And if it doesn't work, then there'll be many other methods that you'll learn about in DE that you can use to solve. I promise there'll be very many others. So I hope you got a good understanding of this. Please comment below if you have any questions. Thank you.